We've been looking at solving polynomial equations. In this video, we're going to look at solving inequalities, where the only thing that becomes different is we replace this equal sign with one of the inequalities, whether it has an equal to part or not. If we have a graph, it's pretty easy from the graphs to determine where the value, remember f of x is a fancy way of saying y. In this case, we want to know where f of x is less than 0. Well, that will be where it's below the x-axis. These are all negative y values. So in this case, we see that that's the interval from negative infinity up to -3, and also the interval from -1 up to +2. Because there's no equal to part for the less than 0, if you'll remember from your interval notation, we indicate those with parentheses as opposed to brackets. When we move to the greater than 0, we want to look where the graph is above the x-axis. And in this case, we see from -3 up to -1 in union with 2 to infinity. However, this time we are including those values. So we're going to go from -3 to -1, and then from +2 up to infinity. But remember, infinity always uses a parenthesis because we can never reach that. If we don't have a graph, we need an algebraic method, and that's something called the sign test method. There are 3 basic steps to the sign test method. Once you have it in factored form, then you can first of all find the zeros. And remember, the zeros, we use the zero product property. And so here our 3 zeros would be x equals 2, x equals -5, and x equals 4. Those help us create our intervals. So step 2, we're going to put all of those on a number line. So I'm going to have one at x equals 4, one at x equals 2, and one at x equals -5. This now creates intervals for us. So we have an interval here. We have an interval in between these two. We have an interval in between these two, and then we have an interval to the end. We need to check a point in each of those intervals to determine if the values in that interval make the polynomial greater than 0 or less than or equal to 0. So let's start on the far left. I'm going to check the point -6, which would fall into this interval. All you need to do is take the point, plug it in to the equation or the inequality, but then you don't even have to completely solve it. You just have to find out if it's positive or negative. So here, when I plug in -6, this value becomes negative, this value becomes negative, and this value becomes negative. A negative times a negative is a positive, but then another negative results in this entire thing being less than 0. So this interval would not fall into this inequality because it is greater than 0. When I move to the second interval, I'm going to choose the point x equals 0 to check. Again, I plug in 0 to the original inequality, 0 minus 2, 0 plus 5, and 0 minus 4. This is negative, this is positive, this is negative. All of those together result in a positive. So this is greater than 0. Thus, the interval from -5 to 2 would be included in this solution since it creates a number greater than 0. If you do the same thing and check a point within this interval and a point within this interval, you will find that the last interval also does work. And so our final solution is that the values between -5 and 2 in union with 4 to infinity all make the inequality greater than 0.